This experiment shows light acting in the process of total internal reflection. So we have a laser shone into the back of a Milo can, and it's quite cool because you can see it travelling in a straight line through the water and then going through a hole which has a nozzle on the end, and you have to adjust the pressure a little bit to try and get a nice clean flow. But if you can see the water coming in and refracting and refracting and refracting, and so it appears like the water, or the light's travelling through the water. And if I put my finger on there, maybe I need a white object such as this lid, and you can quite clearly see that the light is being bent due to the process of total internal reflection through the water. So that's quite cool. So it travels in straight lines unless it's changing, going from one medium to another. So that's quite interesting. These pieces of glass also show total internal reflection when you shine a laser into them. So it's always important to note that nobody should ever look directly at the laser, but you can actually see, the camera's not quite doing justice to it, but you can see how there's a red dot there, how the light has been totally internally reflected. It's going through that piece of glass and also through this next piece of glass. So it's quite clear, and you can see the light bending. I'm not quite sure if I can get that clear enough going through. So that's quite a neat example of total internal reflection. This plastic bit here is an example of a real fibre optic cable, and so it says it's capable of having 2,000 calls per cable lifetime, which is pretty fascinating. And so basically a fibre optic cable was just another version of those glass rods. So 2,000 simultaneous calls with the right technology, capable of handling the whole of the USA talking at the same time. So yeah, that's pretty interesting. So we've got a smaller version of that plugged into our houses to have our fibre optic internet. So that's an application there.